In this video, I'm going to demonstrate creating a corridor model for a lateral ditch, which will be tied to the slope stake line of the roadway corridor model. So first, as before, I'm going to make sure that I have a active existing terrain model. I'm going to make sure that I have a template library loaded up, which I do. And now I'm ready to go ahead and create the corridor. So I'll go to New Corridor. And at the prompt, it says locate the corridor baseline. And now I'm going to use the slope stake line as the baseline for my lateral ditch. So I'll select that line. Reset for active profile. The slope stake line does have its own profile generated by the roadway corridor model. So I will reset. Corridor name, I'll give this a name, call it lateral ditch. Or if I'm using standard terminology, I'll use the L line with a station on the left side. Now the next prompt is to pick a template. I'll press Alt down arrow key to bring up the pick template dialog. You can see the lateral ditches are divided into different categories depending on the type of ditch. I'm going to be using a lateral ditch with a berm, so that will be in the DDE category. I'm on the left side of the road, and I'm going to use a Class B riprap ditch. Data point to accept that selection. And then for start and end, I need to identify the beginning and ending point of my corridor, and I've got some lines here to identify where I'm going to start and end my ditch. I'm going to start there. I'm just identifying these points by snapping to the graphics in the file. And then the last step is to enter an interval, and I'll accept that 5-foot template drop interval. And there's the corridor, the initial corridor model that's generated. You'll notice that there is a low point in the ditch. The reason for that is that the ditch corridor is following the profile of the slope stake line, and the slope stake line has a low point right about here. And at this point, the ditch has a uniform depth. It's just simply applied the default that we called up, so that the ditch bottom is a fixed distance below the toe of the fill slope. So what we need to do now is to provide an independent profile for the ditch. And we're going to do that through using point controls. Before creating point controls, I'm going to create a profile for the center line of this ditch so that I can identify what point controls I need. So I'm going to select the center line, open profile model, and you can see how the bottom of the ditch is following the profile of the slope stake line. And so I need to put in a profile in here. So I'll go to Geometry tab under the vertical and Complex Geometry Profile Complex by PI. I'm going to use Civil AccuDraw to put in the series of PIs. I'm going to put this in, make sure this is in station mode. My first station will be at 0. I'll press enter to lock that station in. I'll put it in elevation of 875.27, press enter, and then data point to accept that point. My next point will be a station 167.27, enter to lock that station. Elevation is 869.67, press enter to lock it, data point to accept it, and then the last point will be at the end, which will be 322.85, enter to lock that, and then put in the elevation of 867.98, enter to lock it, data point to accept, reset to complete the process. Now I forgot to set my feature definition like I should have at the beginning, so I'm going to go back and apply that now. I'll go ahead and set the proper feature definition. So I'll go to Geometry under Standards, Set Feature Definition. Double check that I've got the right feature definition, and then I can go ahead and select that and accept it, and now I have the proper feature definition. Now to do my point controls, I need the PI data relative to the stationing of the slope stake line. As it says here at the top of the profile, the stationing here that I put in was relative to the center line of the ditch. So they're two different things. I need to get the stationing relative to the slope stake line, and I'll do that using the Analyze Point tool. Select element to analyze point. It's asking me to select the baseline. So that's the line I need, the slope stake line. And now I can get those points in the stationing that I need. I'm going to snap to that point, and you can see the readout there down here in that dialog, and those are the points that I need. It gives me the station at each of those points relative to the slope stake line. And I'm going to make a note of each of those and write them down. Now that I have that information, I can create my point controls. And I'll do that by going to the corridor model from the flyout menu, corridor creation tools, point control. I'll complete this dialog box. I'll put in my first station based on the information I got from the Analyze Point tool. So the first station was 415.94. The second station was 582.98. I'm in control. I'm going to give this a description of ditch invert, and the point that I'm controlling is the ditch bottom in. That's the inside bottom of ditch. I'm going to use a control mode of vertical and a control type of elevation and grade, and my first elevation is 875.27, and the slope going out is 3.3525. Once I've entered all that, I'm just data point to accept my inputs. And you'll see the profile update. So now I've modified the bottom of the ditch to match the first leg of my profile. Now I need to enter the second set of point controls. And that will go from station 582.98 to 734.34. Same point that I'm going to control the ditch bottom on the inside. Change my elevation. My second point to 869.67, and my outgoing slope is now minus 1.1165. Data point to accept the inputs. And now the profile has been modified to match my preliminary profile. And now if I look over here and look at my contours, I can see that I no longer have a low point. I have a continuous slope along the ditch, which is what I want. I want to turn off the contours and look at the template drops in this area because I have a lot of horizontal alignment change. So I'll go up to my level display from my 3D model, and I'm going to turn off the contours and turn on the template drops. And you can see that I have some crossing templates and some problems in here. This is typical of lateral ditches that are generated this way if you have these kind of angular deflections. This method works best if you don't have these kinds of angular deflections. If you have relatively smooth, continuous slope stake line, this method will work really well. But if you have these kind of deflections, then another approach. You can take another approach to address this issue, which I'll show you in a moment. If the slopestake line has angular deflections like this, then there's another approach that you can take to address this issue. What I've done is to lay a horizontal alignment on top of the slopestake line. And you can see that if I temporarily turn off the roadway corridor model. So I've created a control line, a horizontal alignment using the geometry tools, complex by PI, and simply snapping to the slopestake line. And you can see all the PIs that were created by snapping and the snap indicators. You can see the key snap indicators that are there, showing that I have created a snap rule to the slopestake line for the roadway corridor. If the roadway corridor model changes, then this line will change with it. It will shift. But now that I have my own line, I can now go in and take out these rough spots, these angular deflections, and add horizontal curves. And that will take care of the crossing template issue. So I'm going to go to the Geometry tab and to the Table Editor. The prompt asks me to locate the alignment, so I'm going to locate my alignment. And I'll get a table of all the horizontal tangents. And I want to go to the locations where I have the angular deflections, and they start around this location right here. So I'm going to start adding some horizontal curves. I'm going to change this to 50. And the next one, just put in these don't have to be big curves. I'll put in small curves here. And lastly, 25. And that gets me through this rough patch. And I'll apply. And now I have some nice, gentle horizontal curves in there. I'll close that. In the first lateral ditch example, I used the slopestake line, which had its own profile from the roadway corridor model. But this line does not yet have a profile, so I need to give it one. And I'll do that by draping this line over the existing terrain model. I can do that by going to Profile Creation, Profile from Surface. I'll follow the prompts, locate first element to profile, reset to complete, locate the reference surface or reset for active terrain model. I have an active terrain model, so I'll reset. And then I'm going to accept, I'm going to lock to start, lock to end, and accept all, data point to accept all the inputs. All right, now I'm complete. To take a look at that profile, to confirm that that's there, I can open up a profile model. If I hover on that, it'll tell me that I have a profile. It says it's a surface profile. To save a little time, I've gone ahead and created this corridor model using exactly the same procedure as before, except that when I put in the point controls, I use the stationing from the ditch center line itself because I'm not using the slopestake line anymore. So let's take a look at the crossing templates now. And you can see those template drops look pretty good. I don't have any crossing template issues. So that's a procedure that you can use to get through any difficult areas that you might have.